Hope you're all keeping well. I'm Nanda Kishore. So I'm a volunteer at the Education Society chapter of the Victorian section and a part of ISDA organizing committee. So before we get started, just a bit of housekeeping stuff. This is going to be roughly a 45 minutes talk followed by a question and answer session. Please use the Q&A window to type your questions during the session. You may also raise your virtual hand from the bottom tab so that we can unmute you if you have a lengthier question, or you can, if you want to ask the question directly. For any other queries, use the chat window to write to the organizers. So after all the organization, we are finally into the final week of the ISDA IoT Symposium. So this is a technology session titled Arduino for Data Analytics, IoT, and AI that's being organized by the Education Society chapter. It gives me immense pleasure to have Mr. Massimo, business developer for Arduino, as a guest speaker for today's session. Thank you, Mr. Saki, for joining us today. Mr. Saki is an industrial automation expert with over 20 years of experience in multinational contexts. As business developer for Arduino, the first open source electronics platform, he supports makers, educational organizations, and professionals in the APAC region. He got his degree in electrical engineering in Italy, where he was born and spent most of his life. He then started his career as an automation engineer in the heavy industry, implementing automation of plants for production of steel. He worked as an automation manager in logistics and then as a product manager for a worldwide leading manufacturer of industrial sensors. In 2015, he moved to Australia, and recently he joined Arduino, bringing his experience to support the expansion of the company in the market of industrial solutions. So he likes supporting customers by identifying existing or new solutions to digitize their processes. His passion for innovation and new technology drives his interest for IoT and cloud application, as well as for implementation strategies of Industry 4.0 concepts. So I won't go into much detail. Without any other delay, I'll hand over the session to Mr. Saki. Screen is all yours. Please.
Thank you very much, Kishore. I'm very glad to be here today and to have the opportunity to talk about how Arduino can support the educational market and the technological stuff with technologies involved in artificial intelligence and IoT. So today we would talk about, well, I will give you a short introduction about Arduino for those who don't know us, and the approaches and the activities of the Educational Division, some fundamentals about Internet of Things, and a couple of kits for learning IoT principles. We will talk about artificial intelligence and machine learning implemented with the Nano 33 BLE Sense, one of the latest Arduino boards. And then we will talk about machine vision with the Arduino Portenta Vision Shield. We will talk about remote learning as a new model and with the Arduino certification program as well, and all the benefits that we can bring to people entering into the professional world thanks to all these technologies. But let's start. So, what Arduino is? Arduino is a complete open source ecosystem composed by hardware, software, connectivity, cloud, and content platforms. And at the basis of the philosophy of the company, there is really the willing to support the innovation by making complex technologies simple to use and available to everybody. We have organized a complete path from learning to prototyping to professional deployment of complete solutions, industrial automation solutions and IoT solutions, thanks to 3 different divisions of the company focusing on these markets. And then specifically focusing on STEM education, industrial automation, Internet of Things, edge computing, and machine learning. And typically the approach and the activities of the Educational Division of Arduino are organized in such a way to support the easy learning and to promote also the invention and the proactivity of the students. So Arduino really wants to make technology, programming, all these tools accessible to everyone, with the mission of organizing and creating the next generation of scientists. And we do this thanks to a dedicated team consisting of education experts, content developers, engineers, we have interaction designers, all people focusing on creating STEM programs and supporting the needs of teachers and students throughout the educational journey that they can have with the Arduino content. You may see here on this slide our values, the values shared by our educational team, and definitely one of the most famous sentences from David Quartierier, who is one of the co-founder of Arduino, one of the professor in a tech school in the north part of Italy, who founded the company in 2005. So we have a complete program from middle school to high school up to the universities for supporting the learning of these technologies, software programming, microcontrollers, Internet of Things, artificial intelligence. In middle school, we guide students from their first steps with those topics into a world of robotics, computational thinking, programming. We introduce new concept in a continuous learning curve, and we also adopt an extensive cross-curriculum open source program to enable all the students to develop the 21st century skills such as collaboration, critical thinking, creativity, problem solving. And we have also teacher guides. We support them with training, and we train them, and we do as much as possible to support every educator and to provide every educator with the tools to deliver relevant, fun, and creative project-based STEM lessons. The same thing is in the high school, where we expand these topics with easy to assemble experiments. Everything is aligned to the NGSS curriculum and programs, and we provide even further level of the learning experience. Till the universities, where the state-of-the-art open sources technology engages students in fundamental engineering concepts, key aspects of mechatronics, complex programming function, and so on, with high-quality learning materials and demanding projects, which challenge the intellectual, challenging the students intellectually and help them developing their engineering skills, while always having a certain level of good fun. So again, the approach is related to creating programs with the next generation science standards, which is the NGSS with K-12 content standards, with all program, including electronics, programmable boards, sensors, accessories, and mechanical parts. We do also a lot of effort to invest in creating the correct principle for managing correctly the classroom. Classroom management is at the heart of the education programs and the kits developed by the Arduino educational team, supporting again the educators and giving them all the tools required to deliver successful STEAM lessons. So we have this classroom management, we have educators, training for educators, supporting them in developing some competencies, specifically when we talk to educators of primary and secondary schools. We have dedicated online content for them. We provide them lesson planning with the content for each lesson carefully planned to efficiently manage the setup, the teaching, and the practical experimentation in the limited time available during the lessons. And then we also provide further support. And in this way, we also provide content related with the Internet of Things, starting from the main concept and the fundamentals, starting from the definition of the Internet of Things, which is a network of physical objects which can interact one with the other, and they can share information and they can perform action. And we do this with the connected devices to the internet. This is the meaning of Internet of Things. We allow them, we allow the device to implement and execute logic to create interaction, to share information and take intelligent action. This is the Internet of Things. And then we are also active in the industrial Internet of Things, which is an extension of the principle of the concept to the industrial applications. Typically, Internet of Things is a word composed by these components and this action. We have IoT with all we call them nodes, the devices with sensors collecting data from the field, transmitting data to cloud platforms where there are big data platforms as well for storing the data, remembering the content of the data transmitted, and then it's possible to use this data to train artificial intelligence and machine learning models. These are used to take intelligent decision, and to send commands back to the Internet of Things devices so that they can perform the action. So this is a complete cycle where IoT is also interfaced to big data, artificial intelligence, and machine learning. And these are the concept linking together this free world and creating a unique ecosystem. And this brings a lot of advantages in different areas, also in our common life, not only in industrial environments or agriculture, automotive, and so on, but also we see application in home appliances. We see the utility and usefulness of wearables device, which are really improving our life, in toys like drones and remote devices. Well, we always use for many hours our mobile. Our mobile is the typical IoT node. which can collect data and can also provide information to the user thanks to the interface with the internet. And typically when we talk about industrial application or professional solution, we talk about consumer and home automation, smart infrastructure, security and surveillance, transportation, retail, healthcare, and everything is connected to the network and everything can collaborate in creating a smarter world, with the benefit of improving the efficiency, with the benefit of supporting the improvements of the health and environmental monitoring, user experience with, for example, home automation, and definitely new business models involved in all these activities where the value of the device is not relevant anymore, but the real value is in the data and what you may do with this data, the value of the data and the new mechanism that this data can provide. And specifically in all this scenario, Arduino is involved in some verticals like smart industry, smart cities and smart homes, smart agriculture, and last but not least, definitely STEM and STEAM education as well, with the possibility of collecting data, creating dashboard on the Arduino IoT cloud, as well as on the common commercial platforms available on the market like AWS, Azure, Microsoft, or Google Cloud, and all the others. Because, and this is typical in the Arduino philosophy, we provide everything under open source licenses, which makes all the information fully available, and a huge community of more than 30 millions of users across the world contributing to all this ecosystem composed again by the hardware, the software, and the connectivity. When we talk specifically about learning Internet of Things, we may talk about the latest educational kits which have entered into the Arduino portfolio, the Opla kit and the Explore IoT kit. These are a complete kit which include all the necessary hardware, all the software, the digital content for learning the fundamentals, and also the support. They are based on the same hardware. You may see this device in the picture on the slide, which is a dedicated Arduino-based device able to run some logic as well as to collect data from the field. It has also a digital an LCD display for visualizing data, but we will see the details in a moment. So both kits are based on the same hardware. They mainly differ in the digital content for allowing a different learning experience. When we talk about the Explore IoT kit, we are talking about a classroom teaching experience. When we talk about the Opla IoT kit, we are talking about a self-learning dedicated to everyone willing to start from scratch and learning really the fundamentals, how to interface everything to internet and to cloud solutions. They are both based on the MKR Arduino family of products, specifically the Wi-Fi 1010 with the Wi-Fi and Bluetooth capabilities, and on a carrier board. We call a carrier the expansion boards. And this is exactly what you see in this picture on the screen. And this has been developed appositely to allow students to interact with sensors and actuators in an easy way. So both kits are very similar in terms of hardware, also in terms of price range, but they both offer a 1-year subscription to the Arduino cloud platform, which is the Create MKR plan. And it's a coding platform allowing to program the board directly from your web browser on a online editor, and then to compile, download the software on the board, and execute the software. Then you can disconnect the board from your computer, and the board can run also battery powered, completely independent. So the device that you've just seen in the picture in the previous slide can be placed, I would say, almost everywhere, and interfaced to other sensors. Some sensors are already included, already embedded into the board. But you may see in this slide the main differences between the two kits. And as I said, this is mainly related to the digital content and to the different projects which are included in the kits. With the Arduino Opla IoT kit, we have 8 out of the box guided projects, while with the Arduino Explore IoT kit, there are 10 different learning activities where students are supported and guided in creating these hands-on experiences, and to they learn while they program and they test these 10 different activities and projects. Definitely with the Explore IoT kit, there is also the complete guideline. Actually 2 different guidelines, one for the students and another one for teachers. So supporting teachers in preparing the lessons for their students. So let's talk a little bit about the details of this product or this device, what the device allows to do. As I mentioned, both have a OLED display, and this can be used to visualize data coming from the embedded sensors or from the external sensors which can be connected. The kit already includes some cables in order to interface very easily some external sensors like the moisture sensor, which can be put in the ground and can detect the moisture of the ground, and a peer sensor to detect the presence of person and to realize, for example, alarms or just to react in some way. We have also, the board has also an SD card holder, so also all the data can be transmitted to a cloud platform, which is definitely the main purpose of an IoT node, but can also store locally for data locking and for further purposes, so that, for example, if we want to have a local storing of the data, we can do that. And even, for example, if the battery goes down, we don't lose that data. Everything is plug and play with the connectors which I just mentioned. And we have also additional sensor like gesture and proximity. Inertial measurement unit, this is a 6-axis, able to detect the inclination, the acceleration of the device, so that, for example, students could put it on a washer machine and detect the vibration of the machine. And if the machine starts vibrating too heavy, then they can raise an alarm, for example, or they can just detect that the machine is really working and it has started working. There are 5 LEDs which can be programmed. Everything can be programmed very easily by using the Arduino language, which is in the end a C++ language. And well, the guidelines are already supporting in the different projects, but thanks to the interfaces, to the sensors available, it's just a matter of proactivity, and students are able to interface additional appliances or add additional sensors, create and program additional applications. So in one case, on the Opla IoT, these are the different projects that are already included in the kit. Thanks to a couple of relays, it's possible to remote control lights, to create a weather station, and to get temperature, pressure, barometric pressure, light, environmental conditions, visualize them on the screen on the device, but also transmit them to the cloud, or eventually transmit them to a mobile through a Bluetooth or a Wi-Fi interface. It's another project is related to the home security alarm. It's possible to create an alarm detecting the presence of people moving in a room, and raising the alarm, sending emails, or interfacing to other cloud services able to send SMSs and so on. There is a solar system tracker able to track the solar position and the intensity of the solar light. It's possible to create an inventory control, a smart garden, thermostat control, and then again other possibilities. It's I would say without limits. It's just a matter of having fantasy and defining new applications. The Explore IoT kit, as I mentioned, start really from the fundamentals, from scratch. It describes the content of the kit. It guides through knowing all the features and the functionalities and the potential of the devices, through graphing data to the cloud, and so on, through different lessons where students are really supported in a learning path. And this is for the different IoT kits. Then we have other solutions for teaching and learning artificial intelligence and machine learning with the Arduino Nano 33 BLE Sense. Arduino is really on a mission to make machine learning simple enough for everyone, and we've been working with TensorFlow Lite, and their team over the past few months, and we are excited to show what we've been up to put together, bringing TensorFlow Lite Micro to the Arduino Nano 33 BLE Sense. This is typically a real good result because up to now, artificial intelligence and machine learning model were used to be run on devices with much more computational power. But thanks to this effort, it's now possible run, well, maybe simple models, but even on microcontrollers boards with very low computational power. So the Arduino 33 Nano BLE Sense has a lot of sensors already embedded on board. It has Wi-Fi and Bluetooth low energy connectivity, and the computational power is enough to run those artificial intelligence and machine learning models. And those are typically related to voice with the digital microphone, motion with a 9-axis inertial measurement unit with accelerometer, gyroscope, and magnetometer, environmental sensors with temperature, humidity, and pressure, light sensors with brightness, color, and object proximity. There are practical reasons you might want to squeeze machine learning models on microcontrollers. And these typically are related to function and functionalities. So wanting to create a smart device to act quickly and locally, independently from the internet. So typically when we talk about artificial intelligence and machine learning, there are two different trends. One trend is to collect the data from the field, transmit the data to cloud platform, and implement artificial intelligence and machine learning models on cloud platforms, where computational power is almost infinite. The other trend is to collect data from by using sensors and IoT nodes, filtering data on the edge by using artificial intelligence and machine learning models running on microcontrollers, and then sending the data already filtered in order to transmit only the relevant data and useful information to cloud applications. The reason of this is strictly related to the costs of the connectivity, to the efficiency in order to have small device, form factor device with implementing the low bandwidth wireless telecommunication technologies available on the market nowadays, like narrowband, but definitely LoRa and Sigfox. And well, also there is an aspect related to the privacy. There are cases where it's preferable not to share all the sensor data externally and just to keep it on the edge. So machine learning can make microcontrollers accessible to developers who don't have a background in embedded development. And typically the 7 steps of machine learning are here visualized, and they realized again a complete cycle, a complete look. We go from the gathering of the data, the preparing of the data, the choosing of the model and the creation and the training of that model, the evaluation of the result and the performances of the model, the tuning of the parameters, and then the run of the model for the prediction of the results. And this goes from requires the business understanding in order to understand what the useful data is for the business model, for correctly evaluating also correct and return on the investment for the project. The data preparation, the modeling, the evaluation, which can create an inner loop, and then the deployment. What we've done specifically with Arduino, and you can find further information at this link, and definitely I will share the presentation at the end of the session. But we have a few different cases. In one case, on the left side of this picture, you may see an Arduino Nano using a digital microphone to hear what the user is saying and to understand if he's saying a yes or no. And on the basis of that, the board and the software program interacts with the digital LED. With the yes, it turns the green light, with the no, the red light. This is, from the application point of view, a very simple concept. From the programming point of view, it's quite simple as well. Programming this example doesn't require so long, but it gives a good visibility on the potential of these technologies on microcontrollers. The good aspect is that the user interacting with the board can change, and you don't really need to change any training, because thanks to the artificial intelligence and machine learning model, the board understand the world, let's say, in a similar way like the human brain does, and it doesn't just compare the word with the recording, but it performs much more intelligent functionalities, which are typical of those technologies. On the right side, you may see another example. The Arduino board is kept in the hand of the user, who is doing different movements. And then the board transmits data to the PC, and the PC, it doesn't only transmit the data, it directly transmits the interpretation of the movement performed by the user. And in one case, the PC visualizes the fist, and in the other case, the arm. And it's a similar concept. Thanks to the sensors, it's possible to discriminate different scenarios. It's possible to train a model so that the model can understand which is the correct scenario. And the movement shouldn't be exactly perfect, but it just has to be in some way similar to the movement that has been trained. This is the real advantage. But again, this is just with the inertial measurement unit and with the digital microphone. But we can do similar things with the light sensors, with the other sensors, and eventually also collecting data from multiple sensors at the same time, aggregating the data, and having the machine learning model interpreting the aggregated data, so that you may understand, for example, that the environmental conditions are good for your veg garden. And this means not only the temperature, but the humidity, the barometric pressure, the light, the sunlight, and so on. And if one of these parameters is not optimal, probably the model can be trained to give as output an action like the irrigation or a motor driving a shade shield or something like this. So, what you need to get started with these technologies, with artificial intelligence and machine learning with microcontrollers. In the end, an Arduino Nano 33 BLE Sense board, a micro USB cable to connect the board to your PC, and then you need to program your board. You can use the Arduino web editor or install the Arduino offline IDE. They are both available for free. And follow the instructions available on this link on the page. Follow the different examples already available there, and we will guide you on those on how to implement those experiments, as well as how to create new experiments. And at the same time, you will learn the fundamentals about these technologies. We are already compatible, as I mentioned, with TensorFlow Lite Micro, with Edge Impulse, which has also a tutorial, a dedicated tutorial available for free on their website and based on this board. And well, we are also collaborating with people from involved in other projects, like the people from ARM, the people from Eloquent Micro ML, and micro tensors. Another thing, and I will show you in a moment, also another application, is related to the OpenMV platform. This is a platform for programming Arduino board, and specifically the Portenta board as well, with MicroPython in order to implement artificial intelligence based also on MicroPython, and specifically on vision. And we will see this in a moment. So let's talk about vision with the Arduino Portenta board and the Vision Shield. So the Arduino Portenta H7 is the first dual-core microcontroller board in the Arduino portfolio. The Portenta family is a new family of products, industrial graded, suitable when performance is the key. High-end industrial machinery, laboratory equipment, computer vision, PLC-like applications, industry-ready user interfaces, robotics controllers, mission-critical devices, dedicated stationary computers, embedded computers, or high-speed booting computation in terms of microseconds. So, yeah, I would like to share with you this video. I hope, yeah, it's visible. Yeah. So as you may have seen, we have the possibility of implementing automatic inspection, machine learning, video processing, metrology application, OCR, with the camera, the embedded camera on the shield, as well as from the audio processing point of view, active noise control, audio event triggers, voice recognition, as well as we've done with the Nano 33, and digital effects. I think that this is quite important, and also with the thanks to the collaboration with OpenMV, this is also programmable with their platform. And well, just a few characteristics of the board. And then I would skip quickly to the remote learning as a new model. Well, actually, the fact is that we start talking about IoT. We then talked about implementing artificial intelligence and machine learning also eventually in industrial application. And then we come back a little bit to the topic of the educational stuff because, well, after the last period, we know that remote learning is a new model, very, very important. And we support this. Typically, all our kits, including the IoT kits, the Opla and the Explore IoT kit, they have online digital content. But we like to expand even more the remote learning support, and we have a dedicated team working on these activities, creating live Q and answer sessions, video tutorials, homeschooling guides, and digital tools specifically for remote learning. And this again is very important because it's not just in relation to the last period and the pandemic, the worldwide pandemic we saw, but also because remote learning allows uh, to learn also full-time worker students or people not really able to commute. And definitely it has also a social impact because it will decrease let's say the fighting for parking spots. It will increase the time that people can spend at home, and also reduce, why not, the pollution due to the commute with cars. But it can also support the educational environment, providing tools for having less crowded classrooms or reducing conflicts in scheduling of different courses and so on. So we really consider that remote learning is very, very important. And typically in the past, this has been reached by adopting tools by third parties, able to emulate the Arduino boards like the Autodesk Tinkercad, which is available for free thanks to Autodesk, which has pros and cons, the typical pros and cons of emulators. We are now also working on a new concept for creating a remote learning laboratory based on physical devices, and where users would be able to interact remotely with the devices. And this is something that, well, will be available, let's say, next year. And then we have the Arduino certification program. We have talked about learning. We have talking about learning from scratch, the newest technologies like IoT and artificial intelligence and machine learning. But one of the key aspects of Arduino is that it's not just related to learning and prototyping. We have completed the experience of our users also in the professional world. So when a student learns the Arduino technologies, then he adopts them for prototyping, and then he will use it for mass deployment in his professional career. So what we have implemented is an Arduino certification program. The Arduino Fundamentals is an online exam that provides this official certification on your knowledge of Arduino related electronics, programming, and physical computing. The exam is available in different languages, but definitely English is fully supported. And it's web-based exam. It consists of 36 multiple choice questions to be completed in a limited time, 75 minutes. And the user receives the results immediately after the submissions. And the results indicates whether the user has passed or failed the test, and passing the exam will grant the Arduino Fundamental Certificate. The exam is based on the concept introduced in the Arduino Starter Kit, and this kit offers all you need, the components, project book, and support to get started with the Arduino and to be successful with the exam. So the certification program, as I mentioned, is based on the starter kit, and this is the composition of the starter kit. What is important is that the certificate is completely unique, with a barcode printed on the certificate, so that a student or a professional could include a reference to the certificate in his curriculum, and he can he can be even more successful in applying to jobs requiring knowledge on this kind of technologies. So these are typically the benefits for people entering into the professional world. Definitely we can support them providing the knowledge of electronics and software programming. We can provide the latest technologies like those already mentioned, but also wireless communication, communication buses, cloud platforms, and so on. The official certification in the curriculum, and the fact that a student learning Arduino technologies will see this and will use the same tools also in his professional career. And typically with the educational kits and the digital content, we also support the development of soft skills, the capability of quick learning, information sharing, team working. And so the suggestion is always to start with the educational kits, but then step to the Arduino Pro products and to use them in the professional environment because they are already fully used in many different companies. We are also going to officially launch a partnership program for system integrators. So system integrators across the world will be keen to hire people having knowledge of these technologies. That's it from my side. I think it's time for the question and answer. I can check on the chat.
Thanks, Mrs. Zaki, for a very interesting talk. That's very comprehensive. We actually have quite a bit of questions.
Yeah.
So I'm
Yeah.
not sure how much time we have, but I'll still go through some of them. Um, so the first one is probably I already covered that. So just dedicated training or course structure for STEM education.
Yes, for both students, content for students and content for teachers.
Yeah.
Absolutely. Everything is online. This content is included with the educational kit, the Arduino educational kits, and is accessible thanks to a special code included in every kit.
Yeah. Okay. Thank you. So other question is that so especially in this pandemic times, we have all read about many reports where you have developed some low cost ventilator or low cost that sort of medical device. So can you please emphasize on Arduino based like any ventilators or medical devices that have been created, of like any recent ones that sort of are relevant to the current times?
We have worked a lot and we have supported many different projects across the world for the development of ventilators in relation to the COVID-19 pandemic. What we've done in the end, we have supported those projects, providing the, supporting the choice of the correct board, supporting the teams in programming the boards and so on. It's possible to find further information on our website. I can probably, I will share with you the link at the end of the session. What we've seen is that all the projects related to ventilators have been quite successful, but the interest in relation to the pandemic has recently moved to other applications, not strictly related to the ventilators, but mainly to the monitoring of social distance and asset tracking. And we have also a solution related to that. Actually, if you know Costa Crociere, which is one of the worldwide Italian branded cruise company on big ships, we are in this period testing the solution on one of their ships, and they have been allowed by the Italian government to restart the activities even with the lockdown, because there is still the second wave in Italy, thanks to this solution. But that's just an example. So actually, the ventilators are still of interest, but we don't see so much new projects. All the projects have been arrived at a certain point, and the companies we have supported, they are already in full production of those ventilators. Actually, no many of them in Australia, because fortunately our situation has been more, let me say, happy than other countries.
Yeah.
And also because there were already companies focusing and producing low-cost ventilators. So we really didn't feel this kind of emergency. But definitely we are promoting the other solutions related to the social distance monitoring.
Thank you. So another question is, how does Arduino 33 BLE differ from traditional Nano boards? The attendee says, I'm developing a blood pressure monitoring system using Nano board. Will these codes be compatible with the parallel version of the boards?
Yeah, the fact is that The Nano 33 family has the same form factor of the original Nano board. So the sides and the pin and electrical connectivity is exactly the same. The main difference is related to the computational power, because those boards embed a Cortex M4, which is a microcontroller with a good computational power. In terms of blood pressure monitoring system, well, typically it depends on the kind of application, but a software running on the Arduino Nano board will run also on the Arduino Nano 33 for sure in terms of computational power. If the user wants to take the advantage of the additional features of the specific Nano 33 BLE, it means the Bluetooth Low Energy embedded into the board, then he will need to add the additional management of the software. Yeah, but what he has already developed will be 99% or 100% compatible, and it will run even better.
Thank you. Thank you. So I had one. Okay, I think Mr. Harvey wants to ask a question, so I can unmute him. I think.
Just one question, Massimo. Is it feasible to have a face-to-face, hands-on workshop at the moment, or does it need to be online?
It's possible to organize that, yes, for sure, because actually the regulation restrictions allow to do that. So that's not a problem. If we organize that in the CBD, that's not a problem at all.
Thank you. Yeah.
So I had one last question myself. So if so you're mentioning about the machine learning part and other things. So are there, so how so with advanced machine learning, especially with the so-called neural networks and other things which are the rage nowadays, which require significant higher matrix multiplication and things like that with the GPU and all those things. So what exactly is the Arduino support in those sort of
one thing that is necessary to clarify is that it's possible to run, let's say, simple models, but on the boards, but the training of the models has to be done on an external device.
Nice.
Yeah, because typically the training of the model, which in the end involves the creation of the neural network, is the part requiring most of computational power, and accordingly to the model, to the size of the samples, the sample set, and so on, a simple microcontroller wouldn't be able to do that by itself. Even if I would say that things are improving, you know, technology is improving so quickly. So at the moment is just like I said, but I would say that we will see new possibilities in the near future.
Okay, thank you so much. Thank you so much, Ms. Vaki. That was a very
6 o'clock.
very interesting talk. Thank you so much.
Thank you very much for having me. It's always a pleasure.
And to all our attendees, we have one last workshop session tomorrow. That's Wednesday, 2nd December at 6 p.m. by Dr. Sanjay Patil on the topic Bioinformatics and Python to Untangle Genomes. So we're all looking forward to seeing you again. Until then, please stay safe. I'll see you. Thank you.